This is a re-recording of a talk I gave at Configuration Management Camp in Belgium, February 2026, introducing a new configuration manager that I'm working on. I've been working in this space for a very long time. I've had some ideas around a different approach to configuration management, maybe 13, 14 years ago. I never had a chance to really build those, and recently, had some time, so I'm showing that now. The focus is around just applications. I'm not looking to build a new systems management system. I suspect we could apply these libraries and approaches to systems management, but it's not the space I want to solve. It's not 600-700 resources, thousands of nodes. I'm focusing on an application. The genesis for this is that in Choria there's a system called autonomous agents, and an autonomous agent owns a thing, and so that could be an IoT device that is attached to a sensor, and that sensor is pulled frequently, and then based on the values of the sensor, basic ranges and so forth, it could reach out to a smart plug and turn a heater on and off. The system is small enough to run on a Raspberry Pi 3. You can run 5, 6, 7 of these automations on a single Raspberry Pi 3, but you can think of it a little bit like a small Kubernetes operator. On the other end of the scale, you can manage full clustered applications. I manage NAT servers with mine. The autonomous agent takes care of things like rolling restarts and rolling redeployments. I do a put into key value store. The autonomous agent listens for the data, and then they do a rolling upgrade automatically with no orchestration. And so the system scales between really, really small to clusters to very, very large clusters. We've run this technology on millions of nodes. And so it's between applications and edge systems and so forth, but the focus is always single application, single unit of thing. What they did not support until recently is to configure that things, and so I've had to rely on configuration management or some other methods to get the software directories, configuration files, permissions, users, etc. in place, and then Choria can manage that application, and so there was that separation. I want to close that gap and bring configuration management into the autonomous agent systems. Now that's a whole different story. I'm working down that path. First step was some libraries. Once I've had the libraries, I looked at some other use cases that I've been wanting to solve for a long time. And really it is about this ad hoc, ephemeral, snowflake, every machine is unique kind of nodes. This is not things that we tend to configuration manage. It's an anti-pattern. Don't do it. Software doesn't work for that. It's also just a bad idea. But I think there is something there, and the background is that a lot of us have many VMs that we do some testing on. My role now is more about architect, product owner, developer, these kind of areas, and I work with a lot of teams who are going through various stages of their product cycle, and a team can come to me going, we have the smallest of a possible POC here. I will try that on a container, see if it works, give them some feedback, throw away on the container. But once that product gets, let's say, traction and development starts, we'll go for a cycle of feedback, and I keep getting newer and newer builds of the software. Now, I would typically at that point create virtual machines for this software, because they're going to be around for a couple of weeks or a couple of months while this project is ongoing. And these machines, they're going to stay around for a long enough time that it's annoying that they don't have all of my standard utilities and dot files and editors and so forth on them. But they're not long enough to make it worth putting them to my full management system, because then I get backups complaining and monitoring complaining, and all these things. There's a middle ground there that is unmanaged at the moment. And my focus is those machines, and so both to get me to feel like home on a machine as good as possible, but then as the software goes, today maybe it's just a single binary. Tomorrow, it needs a Redis instance to go with it. A couple of weeks later, now we need an Apache server. A couple of weeks later, now we need to be able to send SMTP. And so in order to give guidance, I need to grow my platform that I'm using to test the software out over time. But I'm always hand hacking this machine. The constant about this is the software that I'm testing will never again be the same, because it's constantly changing, rapidly being developed. And so there is zero benefit to me creating automation for that particular application. That's not the role. But when I'm told I need to have a web server, I want to get the web server very fast, without necessarily reading readmes and figuring out how Apache works or whatever. And I want it done the way that I'm used to doing it, so that I can get to hit the ground running as soon as possible. I'm then going to hand hack this Apache configuration, let's say. Configuration management should not be stepping on my toe at that point, undoing my work. But inevitably, if I break the Apache deployment to such an extent that it doesn't work anymore, maybe I just want to reset. I run the configuration management for Apache again, and it will restore it back to, hopefully, functioning state, same as configuration management does. And so I want mature configuration management principles applied in a different manner. Scope-wise, back in 2009, I published this blog post, and there were some follow-ups later that really makes people think about package config service. And that describes most software. This pattern is very, very popular within the communities. Some people call it the Holy Trinity even. And it's a model that makes you think about software management really well. The exception there is, of course, library modules. So something like an Apache module, it's a library. It doesn't follow this pattern necessarily, but the applications that you're building does. And so my scope for CCM is around this area. And so it's a package resource, a file resource, service, archive, and exec, and maybe file line. Archive and file lines is ones that I would not necessarily recommend anyone use in production. But for this use case of ad hoc, let's be honest, everyone's downloading crap off GitHub and just deploying it, and that's okay in this use case. And so I want to make that frictionless, and so we're supporting those features. Now I'm going to move in and just show the system in use. Couple of use cases, couple of interactions, and then later on talk about details of some of the things that we're going to show. At a basic level, I want to be able to just do configuration management wherever you are. If you're on a shell and you need to manage one resource, that should be easy. If you like shell scripts, Fish, Bash, ZSH, I don't care, any shell should be able to be used as your driving manifest or your DSL for configuration management. Traditionally, this is quite difficult because doing idempotency, doing desired state, all that kind of stuff in pure shell is quite a pain. But having a set of commands that does the hard work for you, that you can call and drive from shell scripts, this makes that much easier. And so it's quite easy to get idempotent shell scripts once you have these building blocks available. Now you'll note I'm using terminology that if you're a Puppet user you'll recognize, and you'll also note that the shape of things is very Puppet inspired. That's deliberate. I think Puppet had a very good set of names for things. Naming things is very hard. I don't think I could improve on those names, and so I'm going to use those, and it also creates familiarity. Now it's worth noting that this is not a porting exercise. I'm not porting Puppet. I'm not trying to destroy any one configuration management through making this. If I'm only using terminology and shapes of things, this is an entirely clean implementation. There's of course some inspiration I take from Puppet. It's inevitable. I've been using Puppet for a very long time, and some things like how you do version comparisons. Those things I would have lifted from the logic from within how Puppet does it, because Puppet has probably at some point just gone to the Debian web page, coded that stuff up, and it's easy these days with an AI to port the code. But the resources and all that kind of things is fresh installed, fresh builds. Of course, not everyone's into shells, and so we have a manifest, and of course, flavor of the moment is kind of YAML. But don't necessarily think about the manifest as YAML. This is not the destination. Think of manifest as data, because once we have manifest as data, it means we can type it using a reasonably convenient, marshalling format like YAML, but we can generate that in many other ways. And so, if you look at the screen, we have a number of user interfaces here. The background one is a graphical user interface. It's called CCM Studio. This can make resources, data, hierarchies, templates now, all that kind of stuff, and it's a little editor for manifest, and it produces YAML. On the top hand, we have something that resembles a Puppet DSL. I just told Claude, look, make me a thing that parses this file, and then use the CCM APIs. There's a standard in to standard out API. You just echo a JSON file into it, and it gives you a JSON status out of how it's managed the resource. And so that's really for integration with just anything. You can write Perl, Ruby, Python, whatever DSLs you want, and all you have to do in the end is send JSON in and out of the system. And so the one at the top left, the Puppet one there, that uses that mechanism. The one at the bottom that looks like a chef recipe, same system. In the middle, I'm showing a Claude prompt. I've told Claude to make me a Redis module that has, middle ground level of settings and so forth. I haven't used Redis for 10 plus years, so I wouldn't be able to do this without significant time investment. But by providing Redis with a skill, and and by providing Redis Claude a skill and some guidance, it knocked it out. I got a module that installed Redis the first time. You can imagine that we could use a Q language to transform into YAML. We could use something like PQL to transform into YAML. I want to see the YAML manifest not as the destination, but as a stopping point or as a point of integration. And if you like typing the YAML, type the YAML. It's all good. And so there's quite a few. There's many ideas around there. CCM Studio is real. You can go access it and use it today. And a module manifest, once you have it, can be put into just a file or a directory. You can load the tarball onto a web server, onto a Natch object store, and you can run it from wherever it is. You can also overlay hierarchy data over the manifest. So if you have environmental data, like for your laptop or your home lab or whatever, supply the data into it by pulling in hierarchy data. Hierarchy data can come from key value stores, web servers, local files. It is local first though. There is no required networking features for any of the core capabilities. And when there is networking, as you can see, I'm committed to supporting different protocols, different backend servers, different technologies. And so I'm looking to maybe add Redis protocol for the key value, etcd, whatever. We'll add a few. I really want to meet you where you're at with your stack. The ad-hoc use case has some interesting things that we have to solve really to really lower the barrier. Installing Docker these days from scratch is so easy. You go to the Docker website, you copy and paste like five lines of shell, and you have Docker running. Like, the barrier for installing software is pretty low these days. And so to really try to make that even lower, you have to do something different from what we've done before, which is go to a forge, read the README of a module, study all the parameters, study all of the various inputs, and then you've basically just taken one configuration or one step of processes and turn it into potentially even harder step of processes, which makes sense in the systems level configuration management. But if I want to lower the barrier to entry for getting arbitrary pieces of software onto a machine, we need to go quite deep. And so what I'm showing here is that CCM on its own doesn't have a Docker command out of the box, but CCM is a vehicle for plugins. And so the plugin in this case is a YAML file. It just describes the shape of the application and what to do. So when I run CCM docker install, it can either perhaps prompt me, do you want to install Docker Desktop, Docker CE, or I don't know, this Docker Enterprise distribution of Docker. Which version do you want to install? Latest? Any? A specific version? It can take you through a form, and all the while giving you context, giving you feedback, and it just interactively guides you through what you're doing. That way you're in your shell, you never have to leave it, you never have to go to a different user interface, browser, or anything like that. No copy and pasting of anything. The system immediately guides you through getting the software on as quick as possible. The answers that you're giving in this interactive stage can be saved, and later on you can just rerun the answers basically to get the same software installed. They become data input. You can, of course, on the other hand, just add flags. CCM docker install dash name docker ce dash version present, and it will do it. It will invoke the manifests. Post install, you can have a number of utilities. Here I'm showing the latest utility. It's just a shell script. Docker ps, a few greps, a few awks, a few xargs, boom, you're done. But this wraps that in a beautiful utility. You can make nested commands, you can debug you want, and all you have to do is drop a YAML file into a certain directory, and CCM expands itself with all of the various toolings, installers, etc. that you want. AppBuilder is quite an interesting project. It's a sister project of CCM, and so it's worth checking out. It provides the framework for creating CLI tools in a no-code manner. So you don't have to code the CLI. You just drop down the framework, call out into scripts. It has built-in various things for doing transformations of JSON, for graphing JSON, for generating reports. All the kind of capabilities is built into AppBuilder. You don't have to install any additional tools. You just have to configure them in the YAML. Once you've made an AppBuilder plugin, you can just drop it into CCM, or you make a standalone tool, or drop it into some other software. It's a really nice little system worth checking out. Now we can get we can install the software very easily, but what did we install? I don't use Redis very frequently, and so I might need a refresher of what I installed where. And here I'm showing that a manifest can have a post and a apply feedback section inside it, and this is a template, so you can fill in all of the answers the user gave and give the quick refresher on what was installed, how to use it, what file locations and such. So this really underpins the ad hoc nature of it, so that anyone can make really easy, quite high quality installers, really, that wraps these manifests. The end outcome is that you basically end up with a bunch of utility bundles or modules. Here I'm showing them on the Natural Object Store. I will make some tooling in CCM to do this, to manage an index to modules and an index to plugins. I haven't had time. It's a new project, so that's the reality of things. It's a new project, But here we're just showing these are the kind of bundles I have. When I get a brand new machine, I just run the Bootstrap bundle that pulls down my common, RPMs that I like on a machine, sets up my user, sets up a bunch of things in etc. Maybe install a few CCM plugins so that I have a CCM SMTP, for instance. And then, I can choose your own adventure. A la carte menu for configuration management here. I can decide to set up my dot files if I want them. I can set up a Docker, Apache, SMTP relays, NAT servers, whatever I want. And they are run one-off. You just run the module. Doesn't mean that there's a agent that's going to keep running this module. There's no continuous enforcement by default. You can have it. We'll see later. But it's just a dip in and dip out, a very convenient way to run a particular module and a particular bundle of automation. To support making this a really easy to use system to just get into and use, it is a single binary, statically linked, zero dependencies. Coming back from a world where there's 700 megabytes of files in Puppet Labs, and it's I don't know 70,000 files roughly. This is that's not a good experience. You just want to start anything in Puppet and it takes more than a second to start the command. It destroys the interactivity and the flow and the joy of using that command. Where CCM, very easy to get going and it's extremely fast. This is not about a live demo. You'll see later on some timings, but it's a joy to use because of this aspect. This is editor me from the future. I just want to clarify something here. I'm not necessarily saying this is a bad thing about Puppet, because Puppet is a command or a system that you start and you forget about it. The interactivity doesn't matter. But what I am saying, last time I tried to do this, I had the idea to use Puppet's libraries, and I wanted to even be interoperable with Puppet so that from a YAML manifest or from these commands you could invoke Puppet classes and Puppet modules. And in that use case, the performance overhead of having to start Ruby and loading all the libraries all the time and the speed of factor and so forth, it just was not viable. And that hasn't really changed, and that's fine for Puppet because it's not an interactive tool. But for this use case, I needed something else, and so we have to do something else. So I experimented with this, like I mentioned elsewhere, 13-14 years ago. I have a screenshot up about the how that looked, and you can see it's very similar to the manifest and so forth, except I was interoperating with classes and modules and stuff like that, and that would be a great outcome. We couldn't get it done at the time, but water under the bridge, and we're here now, and we're trying something else. Okay, back to the previous recording. And so that is a little bit about the scope and the audience for this tool. I want configuration management in command lines, in shell scripts. I want there to be manifests. I do want there to be continuous management of resources where I want it. I do want to be able to run this at scale as part of a large a large automation system, and hence the integration into Choria. And at the end of the day, I want Go packages that I can use to build these kinds of tools. But at every point along the line, from CLI to Go package and everywhere in between, I want very good configuration management. That means idempotency. It means desired state based. It means data and code separation, hierarchical data. Even on the CLI, I want you to be able to use hierarchical data. I want there to be no or low dependencies. Very, very easy to get going. And that should be true both for the software as well as the infrastructure that it needs to run. You should be able to choose your infrastructure. I don't want to tell you you must have my backend services. You should be able to provide your own using infrastructure you probably already have. Should be a local first tool. Networking should be optional. Networking should enhance the capability significantly, but optionally. And everything should be open and extendable and in a true building block fashion. It's a bit of a tall order. I think I've gotten a model to deliver that to everywhere. And so that's what the rest of the presentation will dive into. A little bit more details about how this looks in practice and in detail. Now, we need to know about our machines. Is it a Debian machine, Red Hat machine, etc. Traditionally, this is done with fax, and CCM includes facts. Here I'm showing just one, deep nested part of the overall fax. It's a little bit different from what you will recognize in Factor. I do want to revisit how the facts look. So far, it's been fine. I haven't felt compelled to do it. But I'm going to come back and look into the facts a little bit more details and make it slightly different or more complete. However, it's already pretty complete. There's CPU, host, you saw the host once, memory, network partitions, all that kind of stuff is there. You can extend it really easily by just dropping data into JSON or YAML files. And it's very, very fast. 0.02 seconds to gather system facts. This means that there is no barrier to having facts any way you need it. To really embrace that, even in shell scripts, any way you need it, just use facts. I don't currently support calling out an external binary to get additional facts. I am a bit precious about the speed, and so we may add it, but for now, this is where I'm focusing. And so there's not much more to say. Facts are facts. They are what they are. It's a well-known concept. And that goes, that's step one towards externalizing data from configuration management. Step two is about the inputs. Which versions, which package names, which service names, which features to create, which users to create, what are the passwords, what are the user IDs, what is my Artifactory service for this environment, what is my database for this environment, or this customer, or this client, or this operating system, or what is the Docker package called in Debian versus Red Hat. That is a very difficult problem to solve, and one that Puppet didn't natively solve for a long time. Back in 2009, I released something called XLOOKUP. In those days, Puppet only had arrays, and so XLOOKUP was CSV based because a CSV row is an array. As Puppet expanded and got hashes, I released Hira, which is the same concept, but for complex data. And this really is a way to model your uniqueness in your infrastructure by any dimension that you want. And so when I released Hira, there was a very important aspect of Hira. And in fact, the first Hira release was not about Puppet. It was a standalone tool and a standalone set of libraries that did this hierarchical data trick. Because I feel strongly that we need to democratize the data that makes up our configuration management. You should be able to use that data in shell scripts. That has nothing to do with configuration management. But if you need to know what the local Artifactory server is, you should be able to ask the same data that also configured your underlying operating system. And so for me, that's very important. There was a command line and it had a lot of UX around that use case. Over time, I donated Hira to Puppet Labs. They put it into Puppet. They rewrote it. They renamed it to Lookup. Lookup is great. No problems with Lookup. But the focus has shifted away from that command line experience, and the data is now kind of locked in Puppet. And it's a shame because I think the data is extremely valuable. And so I made a new take on Hira. It's a re-implementation, rethinking some of the ideas, And as you can imagine from what I'm saying, accessing the data in other scenarios is key. And so in the basic sense, it's not earth-shattering. We have some data, I resolve it, I get the data out. A key difference though is that you're getting the full data structure out. It's a single shot. In Puppet, Hira is about passing in values as parameters for classes, and so that is inherently a key-oriented approach. And for good or bad, the value of a certain key can change even between classes, so the call site changes the data. There is no single representation of all of the data in a single Puppet run. In this use case, I don't have that constraint and I don't have that need. And being able to one-shot out all the data makes it much more approachable and understandable and debuggable and so forth. And so I took that approach. One shot, kicks out all the data for your system, and that's it. Of course, you can query into the data if you need to get only, let's say, all the package-related information or even just the package name, but it's one shot. All the data one shot. It's an important concept. Here, of course, we have a hierarchy. It wouldn't be Hira without a hierarchy. And I create an order by which I want to be able to merge and override and augment data. And that is, of course, fact-based, just like in Hira. Unlike Hira, this between the curly braces here, that is a full tiny language in there. I could look up my location, I could downcase it or uppercase it or whatever. There's a whole series of functions that I can use. I can even go as far as do things like count the entries in an array or search in a array of maps for a certain item. Find my ETH0 among a list of many network interfaces, and then use the subnet of that network card that I found as the override. There's a full language in there. I didn't do that for traditional Puppet Hiro because the data was already very complex to understand where your data comes from. Because people make 50, 60 tiers, hundreds of files, different values at different times. If I added also that level of mutation to the data, stored procedures essentially, you would never be able to know what's going on. But in this case, with the smaller scope and the single shot resolving, it's more approachable, and so I expanded out the capabilities there. Once you've configured your overrides, you just say this is home, this is production, and I'm creating specific data that I want, and it knocks out. You can also create additional data here that wasn't in the original set of data. So you can add information at the level of an override that wasn't in the original. That's maybe an unintended side effect, but that's how it works today. What's different about this Hira is you just chuck everything into a single file. It's one file that holds the data, the hierarchy, and the overrides. So think of this a little bit like your module input, if you want, your module data. And so it's all in one go. Because it's all in one go, and there's no kind of magical resolution of individual files and extra files, etc., we can, very easily move the file, put it different places, etc. But first, we support getting data out of the system in many formats. Here I'm reading data.yaml. I'm giving it a custom bit of fact. So this is location fact with a value production. And it will just render me out the data that matches production as JSON. I can also ask for YAML. I can also ask for shell variables. And here we can see I'm querying into package. So I'm only getting the variables for package. And this is great. You just eval this thing into a shell or a shell script and use the data. That's it. You could also, of course, do query package.name, and it'll give you Docker desktop, not the full structure, and you can just backtick that into, or dollar brace that into a single variable. Really easy to pull out information out of this hierarchy, and wherever you want, and wherever you want, and in whatever format you want. If there's work I can do here to make this integration into other systems better or easier, let me know. I'll do that work. Because it's a single file, it's really easy to put a single file just wherever I want. And so here I'm creating in my NAT system a key value store. It's a replicated key value store across 3 nodes, so it's reliably stored. And I create a historical record for my data, so I can go backwards over time and see as my data change, maybe revert back to a previous instance of the data. I put the data into my key value store, and then I ask Hiera to resolve straight from the key value store. The results are the same, the output is the same, data is the same, everything looks the same, but it just fetches the data from the key value store instead of locally. The same works with HTTP. I mentioned I want to also support things like Redis, maybe Valkey, etcd, whatever. You let me know where you want to put your data. We can support something like that. But of course, it's optional. We saw normal files. Now that's about what I have to say about Hiera. It is Hiera like you're used to, with a little bit of a twist. There's nothing earth-shattering new there. But I really want to bring us back to being able to democratize the configuration management data. Now, how you actually interact with the configuration management aspect of this, how you use the data, and how you actually affect change. Well, for that, on the most basic level is on the CLI you manage one resource. If you want to manage only ever just one resource, that's fine. This means I can move from a Debian machine to a Red Hat machine to somewhere else where I have providers, and I don't need to remember the details of the operating systems. I can just say CCM deal with that for me, and it will do that. This is, quote unquote, good configuration management, idempotent, desired state, etc. We'll get to that in a bit. These commands, though, they're not like auto-generated like it was in the Puppet resource command. They're uniquely crafted. They are good Unix utilities. They have help, they have flags, they have arguments, standard out, standard error, all the good stuff. They have command line completion. They integrate with that little command called cheat. I can emit cheats for you into the cheat application. It's a good, high quality, fun to use, easy to explore, easy to discover way to manage resources. You don't have to go to documentation to learn how to use a file resource. It's all right there. Low friction, and they're very fast. If you manage a file from a template, you are talking about single-digit milliseconds to do that. They are idempotent. Idempotent means the same command ran multiple times will have the same output, same effect, essentially, on your script where you're calling it from. So if you were to run CCM ensure docker, CCM ensure package docker in a shell script, no matter what the state your machine is in, the shell script should always just see success. And in the background, CCM should upgrade or downgrade or remove or install or whatever needs to be done to get your system to the desired state. And we see here we've got timings 7 milliseconds to manage the package. That's not a lie, that is how long it takes. CCM is very, very interactive, fun to use. Because we are idempotent desired state, we have all of the kind of mechanisms inside to be able to do a no-op. No-op is deeply flawed as a concept. I didn't fix the concept. But if no works for you in other systems, this is going to be the equivalent level of feature. There's a third run mode that I will get into later on. But for now, you can either do it or you can ask it what would you do if you were to do it, and that's actually quite useful in this isolated case. Obviously, we want to bring in some hierarchy data. You have a multitude of ways to go about that. Here I have a file called .hira in my local directory, and I can resolve it as environment variables you saw earlier. I can just eval that, and then I can use those variables like I would any shell variable. This is one way of doing it, perfectly fine. We can see the values got interpolated into the command, shell stuff. That's what shell stuff does. There's no surprise here. But you can bypass all of the variables and just do a lookup inside your shell command or access the data directly, and it will do that. It defaults to .hira in your current directory. So if you have multiple projects, multiple environments, multiple places, just put the file down and all these commands will automatically do the right thing. You can also, though, use the fact that Hira is connected to the network. So you can either pass --Hira and the URL, or you can set CCM Hira data, and then automatically Hira and the package command, the ensure command, is going to just use that data. And so suddenly our single command line tool has got a network capabilities, and it's pulling data from the network, and it's got centralized data, centralized desired state, centralized knowledge that it can use to do things like find artifactory, etc. And as I mentioned, we support key value buckets also. And so we got all the building blocks ticked. I didn't really show the last bit about open building blocks. You can go CCM ensure API, and then you can echo a JSON into it, and the JSON would basically be a resource, and then it would echo out for you to its standard out the state, and a big chunk of JSON that says what is done, it's upgraded, downgraded, blah blah blah, what's the final state, success or not, etc. And so that building block, just use that to make DSLs in any language you want. If you want to do configuration management from Perl and you don't want to write all the idempotency stuff and desired state, just chuck JSON at CCM, it will do it for you. It's a true open building block even on the CLI and all the other bits. Now, of course, good CLI means good shell scripts. That's the point of having a good CLI, because I want good shell scripts. In this situation, it's a very basic thing, but even getting just this done with Bash is very hard because of the idempotency. All of the logic about should I upgrade the script, should I downgrade the script, should I remove it, should I install it, should I, all of the logic that happens that makes a thing idempotent, you write that in Bash. It's not impossible. I've asked ChatGPT just for lols to turn this into Bash, and it did a pretty good job. I was very impressed. It was less than 200 lines. I definitely learned a bit about reading that Bash script, but you don't want to be doing that, and you certainly don't want to be doing that against multiple operating systems. That would explode the shell script, because now you have to teach it how to do version comparisons for Debian, which is hard. And you absolutely do not want to do it for multiple shells. CLSH, Bash, Fish. And so by outsourcing that very hard part to my commands, the barrier to making idempotent shell scripts is much, much lower. You can imagine dropped a get opt in here, add some flags, figure out, -- package name, -- version, and then you overlay the data in here. You can do case things, you can do if blocks, you can make functions, you can do all this kind of stuff that you want to do. Make an installer, and it will be robust. It'll be able to be run multiple times without just failing because you've ran it once before. And so as a way to write good quality systems management shell scripts, it's actually quite a useful set of tooling. And what I'm demonstrating here is that it is actually idempotent. We at the top one, the file wasn't there, so it had changed, and the service wasn't running, so we start the service. And the second time I run it, everything was still in the same state and running, and so there was no more work to do, and so it doesn't do any work. At the bottom, I show the timing because that is basically the time things take without having to do slow things like install a package. 0.6 second to run that shell script that manages free resources, calls out to CCM 3 times. Very, very, very nice. The interactivity, the reactivity. You can use the system at the speed at which you're thinking, and that's what matters. On the CLI, that's what really, really matters. Now, I would lie if I say this is full, idempotent configuration management, because you really need the ability for the service to restart when the file changes. That is a critical capability that you cannot say you have idempotent configuration management without it. And that's quite hard to do in shell. The way that it's implemented in other configuration management systems is there's an event system and an event store, and every resource puts the state into the event store, and then future resources are querying the state to see, was it a good outcome or a bad outcome, should they react or not, etc. And so CCM has all of that stuff built in, but in the default command line interaction mode, there's just no store, and so it's not persistent. And so if you make a store like you do over here, just a temporary directory, there's no need to preserve it. It will now start storing the state for the package and the file, so that by the time that the service needs to be managed, it can query backwards into the state and say, did the file change? If the file changed, refresh the service. And there's some reporting, of course. If I'm keeping state, why not? I can show you what happened during the run. And at the end of the script, you can just delete it. So you would have a trap and the cleanup function, or probably I should just add a --clean flag to session report, which will delete the store. But this is true, full, idempotent configuration management in a shell script. And this is true also for our exec resource. You've got creates, you've got all those kinds of options that makes exec idempotent, and also we have an archive resource. So if in the shell script you want to download SHA-256 check-it, extract it, copy files out of it, discard it when you're done, don't do it again unless the copied files disappear, etc. CCM's got your back. The archive resource, exec resource, has all of the idempotency features without you having to go write up all of those code in bash or shell, any shell script language. So when you run it, it is the same as before, but here we can see that the daemon file changed and now the servers have refreshed. That means it was already running, it restarted the service because the configuration changed. And we have data in the report that says the refresh happened. And so that makes these scripts essentially transactional. Now, bring in the hierarchy data as central data inside the scripts, of course, is obvious. We've shown that, in fact, earlier. But having scripts, this is important for the ad hoc use case, because I have 10, 15, 20 VMs around the place. Nothing's actively managing those VMs. If my Artifactory moves to a different location, how would I even know where are those 20 VMs? How would I even know what to go update? These machines are complete snowflakes. And so by moving the data out of the shell scripts and into a key value store or a web server, it means that next time I run the shell script, it will automatically, any one of the machines, even the one that was on my laptop closed while the data got updated, all of the machines will automatically have the correct data. And because it's configuration management, the machines will be safely adjusted. And so separating data in shell scripts important, moving our data just into the network with very low friction is an absolute superpower. And we can do the web as well. And so again, scripts tick all of the boxes that configuration management should tick. Manifest, I've shown you the manifest before. I'm not going to go too much into this. You can guess what this is going to do. What I didn't show before is that a manifest is just a hierarchy file. Your data, your hierarchy, your overrides, your resources, everything in one file. And easy to see everything in one place, easy to generate everything in one place from another system. Easy to just know what's going to happen. There's no questions about it. There's some conveniences for writing these YAML files, and so if I do a defaults block, it'll apply to all of the resources below it, and it's run top down, so it's top down ordered. So that's just a convenience, really. When I run it, it looks exactly like the shell script looked, and that's on purpose. I want the move between these two worlds to be as frictionless as possible. But now, being that it's a YAML file, this gives us some additional options, right? I can tar it up, I can ship it places, I can store it in different places, and now this is really what sets Manifest apart from shell scripts, because they have templates, they have sources, all that kind of stuff. Bundle it all up, ship it, and now I have tooling that can execute that, and I don't necessarily have to go, can I run your fish shell stuff on my bash-based machine? Probably not. The interpreter and the executor for this is CCM, and so now it's much more portable that way. I've been using Docker throughout as an example here. It's a decent example because it's got the right amount of complexity and so forth. But Docker is something that I probably would want to just run all the time. I want to manage Docker all the time. I want it to be kept up to date. I want it to be always running, and I don't tend to change its configuration much. So just manage it all the time for me. In contrast that with my dot files. On these Snowflake machines, I am inevitably modifying dot files. If configuration management were touching those things again, it would be bad times. And so I want you to be able to pick and choose between these two models, and it's not an all-in or all-out kind of scenario either. And so CCM has an agent. You give it a list of manifests. It doesn't merge them together or anything. It just runs them separately, and it's going to do it every 5 minutes. There's something very important to note here. The configuration file here. I'm not hiding the fact that there's configuration. There's not like a giant gorilla under the table. There is, up until this point, no configuration. You cannot configure anything in CCM up until this point. It doesn't have a configuration file. Everything just works. Everything just drops in and gets you going instantly. That is the use case I'm going for. And if you know the software I make, you'll realize that it was quite a difficult thing for me to do, but no configuration. Earlier, of course, I showed accessing NATs, and there's credentials and server names and so forth. Once you've configured NATs itself on your machine, CCM will just use the same configuration. It doesn't have configuration for NATs. It just uses the configuration that you've already done for that application. And so anyway, so back to agent. So this is going to do the obvious thing. It's going to run the Docker manifest every 5 minutes. It will watch the object store, and so if I update the Docker manifest or bundle, it will immediately download that thing, update its local cache, and immediately do an apply. And so if you had 20 or 30 machines that has Docker on it, and you put a new module out, they will instantaneously do that upgrade. This is good and also bad, because it can cause denials of service on shared infrastructure, but it's good for reactivity and that kind of thing. And we'll see a little bit on my roadmap on how I make the bad of that a little bit better. But so this is an obvious thing. Now, what I want to do is minimize the impact of these runs. I would like to run them nearly continuously, every minute. There's reasons we'll get to in a bit, but I want to run these applies every minute. And that is a bad idea because you're accessing your package manager. Every time I'm talking to the package manager, I'm making locks. I'm potentially interrupting other people doing stuff on the machines. And so you want to not do that, but you also want to do it. So what do? In a traditional configuration management system, when you say service ensure running, it just checks if systemd thinks the service is running. It doesn't know that the service is doing anything useful. The service could be up and just failing all the time, and doing nothing good. You don't know. And so what you really need is a deeper awareness of what the services are doing. And if the service is up, it's running, it's enabled, but also is it serving my Hello World application? And to give it some time to warm up or to start up or to build caches, we'll give it 5 tries, and you can adjust this time within the tries and all that kind of stuff. And you can put a number of checks. Today the checks is Nagios format checks only. I'm going to put GOS in there also so that you can do quite deep validations of many settings without extra utilities. And just to keep it all honest, this is also accessible on the CLI. This introduces a third run mode. We have the full run mode where it makes changes. We have a no-op run mode where it tells you what it's going to do. And we have a health check only run mode. And so apply and CCM ensure and all of these things have these different run modes. Now in agent, what you can do is tell it health check every 1 minute, but run me full applies every 12 hours. I'm probably going to support a cron schedule there so that you can say only run it at night or whatever. And now it's only doing the health checks, which is very light. They're very fast. They don't call out to DNF, etc., etc. They just do the stuff that you want to do, like, is my web server up? If the web server is not up, it will then trigger and apply as a remediation step. There's controls there about just avoiding like tight loops of fail, apply, fail, apply, fail, apply. And once it's doing that, all of this monitoring state and the data coming out of monitoring, it makes it available on a port as Prometheus data for you to suck down. And so this third run mode means we can make really very fast, really reactive configuration management and monitoring tie-ins. And I'm using it here in the agent, but in Choria's autonomous application management, this is really going to come to the fore there. And so this really is a forward-looking feature, but using it in agent, we can actually solve real problems today. And make these small ad hoc machines, VMs on my laptop, have the impact of managing them be as low as possible, but the benefit of managing them be as as much as possible by joining health with configuration management. So that is what I have to show really in this presentation. The project is very new; it's 2 months old. However, everything I've shown works. I've mentioned throughout there's some areas where I want to improve, like for Axe. My template system is a bit janky. So there's definite orders for improvement, but it is a well-formed system at this point, and I'm using it every day. I'm enjoying using it, and it's solving real problems for me. On the roadmap is some interesting things though. I want to bring some of the features from Choria Orchestrator into Agent and into command line. And so, for instance, if you're managing the package Docker and you're getting that package from a local Artifactory and you have 1,000 machines, the fact that I'm doing watches and immediately rolling out new Docker as soon as it's available is great because it's available, but it's bad because it DDoSes the Artifactory machine. And so I will be able to annotate that package resource with saying it should be under concurrency control, and it has a name, Artifactory. And then the concurrency control on the network has a setting that says 25 are allowed to access Artifactory at a time. And then automatically my 1,000 CCM agents will stall when they get to the package resource. 25 at a time will do the upgrade, and then they will whip through continually. As soon as the one leaves the package concurrency control, another one enters. And so you have a fast as possible rollout without destroying your infrastructure. The other thing to look at there is you can put it on the service, and you can say I have a Docker concurrency control, or I use this extensively for managing NAT servers where you can only upgrade one NAT server at a time. And so I put a concurrency control that has a value of 1, and then I get automatic rolling restarts because only one at a time is doing the restart. And the health checks and so forth means that it will only continue to the next one once the NAT server is fully healthy. In other words, all of the RAW stuff has happened. So by combining resource knowledge with health knowledge with concurrency control, I have high quality full system rolling deployments. I would like a service registry. Even in my snowflakes, I have Prometheus. And so as an application comes up, I want Prometheus to know the application is there, so that if I'm evaluating your software and you tell me you have Prometheus support, I want the friction between having this application running and Prometheus data being gathered to be 0. Prometheus is an example. You could also be like an ingress or some kind of a thing. But what I also want is when I close the lid on my laptop and my VMs go sleep, that Prometheus stop polling those machines. I don't want it to spend any cycles of that because I don't want to have to maintain all of this stuff. I just want to delete the VM or shut it down, and the side effects that it caused must be gone. And so on the Prometheus side, that should be no more difficult than a single CCM ensure file with a template. Nothing more. You stick that in cron and you have your Prometheus magically managed. And the service registry that I attach in CCM resources, where I say take this resource, tell the registry it exists, annotate that with the fact that it's a Prometheus capable resource on port XYZ, that should be baked into the monitoring and managed by CCM. The other stuff I mentioned, queue, I've managed bundle tooling, I've managed secrets are kind of obvious. I don't yet have the need for secrets, but I can see it's coming, so I'll do something there. GOS I mentioned. The second last one about bundles and static binary is quite interesting. I'm going to scroll back quickly here. I mentioned these commands. So CCM Docker install, CCM Docker latest. And that, of course, is coupled with a manifest bundle, and that manifest bundle tells you how to install it, tells you the templates, tells you files to source in, etc. I can take this and compile all of that down to a static binary. The UI, the manifest, the sources, the templates, the libraries for applying the manifest, and the utilities for accessing the install server. I can make it all into a single binary. Zero dependencies, statically linked. And you may not think that's super useful for Docker, but now think about the bootstrap stage where you're in cloud in it and you don't yet have CCM on the machine. That very first bootstrap manifest that installs a couple of YAML repositories and your utilities and a couple of CCM plugins and even CCM itself. That bootstrap stage can be a single binary with zero dependencies. And think about running a single binary in a Docker stage. If I bind mount tempfs into Docker run and run that single binary, and I use configuration management to build a Docker, and then tempfs is evicted from the Docker container, it's never stored, I have a zero footprint left configuration managed build Docker container using this tooling, and it's instantaneously fast. And so that is a area of exploration. I haven't done it. I know I can do it because these app builder plugins are compilable down to static files. And if you don't have a plugin, of course, I'm just going to compile the CCM binary for you. So you'll have CCM with those things built in. But that's the idea of the compilations, to really get that very, very early bootstrap stuff just easy and working. And that's it for the roadmap. That's about what I have in mind. I don't want this thing to blow into an enormous project. These are like my almost fantasy level furthest out roadmap. The system is available today. You can get it at choriacm.dev, and the dashboard I showed you, the kind of visual editor, that's up there also. It's called Studio. Yep. Thank you very much. I realize this was a long presentation, but it's a conference length presentation, and so I appreciate if you've made it to the end. Thank you very much.